Čekamo da se ugasi i kompresor da bi bilo tiše. Uglavnom, ovo nije velik brod, pa makina nije nešto ogromna, nije kao klasičnih brodova, ali poslužit će. Tu je naš kapo, on će nas provesti okolo i reći nam dvije riječi. So,
okay, we start.
We can start.
Okay.
All right, Chief. So, where are we? What are we doing here?
We are in the control room.
Engine control room,
yes,
right?
Engine control room, and we have.
All right.
We are in the control room, and we have control here over all machinery.
All machinery you
yes.
control here.
We
okay.
have the breakers for the power, and we have also the control system on the console.
Okay, let's start from the control system.
Okay.
So, what is it? What is it connected to? What it does?
Basically, it's connected to the all machinery we need.
All machinery, okay.
Yes, and we can.
Deck, engine, all that.
Yeah, we control all the systems, the engines, the propellers, propulsion, steering.
Everything goes on that little screen.
Yes.
Okay, show me something.
For example, we can go to the electrical plant. You see on the screen the bus bar. Bus bar is the place when all the electrical connections from the generators meeting the consumers.
Okay.
So basically if we need the power for the lights or for the thruster, we have to start the generator. It's connected on board, it's running, the indication is green, and then you're transferring the energy to the power to the another things.
Okay, so that was example of power. What else can you see?
We can go to the another screen, for example
propulsion.
Yeah, boat thrusters. We have two boat thrusters, two azimuth thruster. The boat thruster is the thruster that it's not movable, it's just changing the speed of the propeller. And for example, you are going there and you can check the parameters of the machinery, alarms, whatever you need, you know. And you can see, for example, the revolutions and the...
Also, all the alarms are there?
Yes, there is an alarmist. And the alarmist is showing you the present alarms that they not accepted, and also you can go to the log and check
and see the history of alarms,
yeah.
right?
Yeah.
So everything what you need is there.
Yes.
Good. So
then we go maybe to the bus bars.
The bus bars you just show us there?
Yeah. And
okay, this
the ship is built like this, that we have the 690 power, and you have split bus bar here because it's a DP2 class. So you have the space there.
Wait. So, znači 690 volti, podijeljene su na dva dila da bi zašto je brod DP2 i mora moći neovisno raditi.
High dock split.
So why are they separated?
They separated by construction that we have the redundancy.
So it's for redundancy purposes. If one of them fails, the other one will keep working.
That is possible because we have the middle voltage there, but there is possible of an explosion of this box, and then you have the fire, smoke, and also going current and arc. And arc will be destroy everything was on the bus bar. That's why you have the separation.
So that one will keep working if this one fails. Good.
The minimum requirements we have in the class, and you will have the maneuverability and everything, you know.
Okay, so we will have propulsion and everything just on this one.
Yes.
Good.
And basically it's built like this. You have two generators there, two generators another side. You starting, stopping the engine first, then you loading up the engine properly. The another step is you checking the parameters in the engine room, that the engine has the oil, everything what it needs. Then you're going here, and it's a full automatic system. You just push the button and you can connect the power. So basically it looks like an engine, clutch, we call it, but basically it's like an electrical connection to the we have this electric system, so to the breaker. When I push this button, the breaker will be charged.
Okay.
And then we have the energy.
Okay. Good. Good.
Yeah, you have all the parameters there. Must be 690 volts. We have 60 hertz, and the amps are according to the current we take. And
so,
now maybe we can go here also.
Wait. You mentioned the vessel is diesel electric. Can you explain that?
Diesel electric means that we don't have mechanical connection between the engines and the propulsion. So basically it's like this. On the conventional ship you have the shaft, or you have clutch or gearbox or whatever. Yeah. We have connection between the alternator and the engine with the cable going to the propulsion.
So the power is generated in the generators. It goes through all these things. Big cables, and then you got the electricity, and you got electric motor running the thrusters.
On the propulsion, yes, and it's giving our motion. Right.
Okay, good.
The important thing is also that we have different kind of the voltage on the ship. 690 is the like a primary one, but then we don't need so big power to run the smaller machinery, because the problem with big power is you have big cables.
Okay.
It's about the energy losing, it's also about the equipment. So we have the transformers, and we are transforming the energy from the 690 to 480. And here you have exactly same.
So this is where you do that, right?
Yeah, 480, no. Transformers are in the engine rooms because they creating a lot of heat.
Okay.
But here you have the bus bars, and basically this is like a cascade system.
Yeah.
690, 480, and we have also the 220 energy. You have like the panels, and then it's like this. I will open maybe.
Can you open one?
Yeah.
Sad će naš kabel to lipo otvoriti.
I'm using the incorrect tool for it.
Oh, let me take a. Oh, nice tool. You got to do that.
We don't have any proper spanners. Yeah. And it looks like a 220, we can say it's a board. And you have all the consumers there. For example, like a 220, you need the power for the cabins, for the lighting, for the small stuff. Yeah. We're not talking about the propulsion in this moment, and you know. And you can just, you can do just like this, that for example, if you have the breaker, you're going to the breaker and it's in on position, showing there. And off. Always you must be careful, because there is also voltage that can kill you, but all these breakers are plastic, you know. So.
Try not to kill me while we record this. It's my last day. I'm going home tonight.
When I come to Split.
It's really bad time to die, because my flight is tonight.
What do you want to know now? We go to engine room?
Wait with the engine room. Anything else interesting here?
Yes. For example, our generators, they...
Don't overcomplicate it, just simplify.
We have the radiators here on the deck. So basically all the heat created by the engines is going to the water. Water system is cooling engine. It's going then to the radiators. and there is a big fan, and fan is cooling out the heat.
So what you wanna say that cooling is done same like in a car, let's say?
Yeah, like old cars, you have the fan and you know.
Fan, radiator, and that's
yeah.
So you don't need suction from the sea chest or anything?
No, not here. This is designed like this because we are on the lift boat.
Exactly.
We should say in the beginning.
Yeah.
The lift boat is the boat that they can go up.
Exactly.
Up.
So it's not like on conventional vessel.
Yeah.
We don't need seawater to cool down the engines.
Yeah. The only thing
it's
we need
closed
seawater.
System, right?
Yes, it's closed system basically.
Okay.
Yeah. And also we have the drives for the boat thruster and the azimuth thrusters. It's what he mentioned before, that we need to convert this energy to the certain parameters, whatever. And then we are using the frequency converters and the drives. And the energy from that one, from the engines, going to the thrusters. And there is also the machinery that is in charge of it, or whatever, you know. Yeah, you have the special fans and the pretty complicated systems. And, yeah.
What the f is that?
It's also cooled by the water. In this cabinet we have the pumps, and these converters and everything making so much energy that you need to cool it with the water. It's exactly same like we have new processors on the computers.
All right.
Yeah.
So, if you want to be engineer today, you should know something about electrics, right?
No, you should go to that department. Then you don't need to know anything.
Well, that's another conversation, not for this one.
We go to engineering.
They already up. They're already engineering. Wait, there's nothing else you want to show me?
Oh, we have also the safety panels from the fire system.
We can go to that later.
You don't like it.
Okay, so
you show that we have two engine rooms.
Why
separate.
do we have two doors?
Because according to the dynamically positioned class DP2, we should have two separate engine rooms.
So DP2 vessels need to have segregated engine room.
Yeah.
In case this one is, let's say, there is fire or flooding, it's not working.
Or pirates. Yes.
The other one is gonna keep going.
Yes. Yes.
Good.
This is what we said about the redundancy.
Exactly. So same like you have redundancy there, you need to have it everywhere.
Yeah.
So engine room is completely segregated.
Yeah.
There's a wall over there.
And watertight door between.
And watertight door. Okay, let's go to white part of the engine room now.
We can even open.
So this is okay. Can you open the door?
Of course, I will show. Yeah.
Closed. Good.
What you want to know?
Okay, start by important things. Let's go to see generators. You were talking about the generators, so let's start with them.
We have in every engine room here two generators. It's a Caterpillar 3512.
Okay, so two generators on each side.
Yeah.
And these two generators, they are connected to one of the electric thingies you showed me, right?
Yes. And this is alternator, the part of the generator set.
Wait.
So from there is engine, from there is alternator.
Alternator. What does it do?
It's creating you the energy. There is a stator and the...
So it's converting mechanical energy
yes,
to
mechanical
electrical.
energy through the flexible coupling to the electrical power.
Good.
Yeah.
So this thing here is alternator.
We need also cooling a lot. That's why we have filter. Air is going in. The hot air is going out.
All right.
Yeah. Now maybe we go to the starting air bottle, yeah?
Wait, come here. You wanna start it?
No, to start the generator, you need air. This is the most important thing. So we have the bottle. And also about the redundancy, we have second bottle in another room. So you can use it crossly if you need.
Okay, start from beginning. To start an engine, you need air,
yes.
right? This is compressed air, correct?
Yes. You
Okay.
need, between 20 and 30 bar air.
How much pressure you got inside?
Of course 30. I glue this arrow for you.
Okay.
You have always 30.
Alright, so we got 30 bar of pressure inside, and then how many times can you start an engine with this one?
The requirement, I think, by law is that you must have 5 starts, but we have much more.
More than 5 starts,
yes.
Okay.
And to get the compressed air, you have the compressor.
So this is the compressor, this is how you're getting your compressed air.
It's sucking here through the beaker.
Okay.
This is the first stage, low pressure. Then low pressure, like a 5-6 bar, going to the high pressure, and it's going to the bottom.
So, from this compressor, you're charging this.
Yes.
There's a nice little label.
Yes.
You're charging this one, and with this, you're starting the engine.
Yes. Basically, what you have to do, just push the button. In this time, you have the solenoid valve. It's opening you the. We can show it even.
So it's all automatic.
Yeah.
Okay, show me.
Here is this part is the starter motor. The air is entering there to the reducer because, for example, engine needs 28, let's say, or something, you know. And through the starting motor, the air power is converted by the gears, and it's going to the flywheel. Flywheel, it's a big teeth wheel on the shaft.
So with the air, you're actually through these devices, you're spinning the flywheel, and you're starting the engine.
Fuel is open all the time. It's a diesel engine. You don't need any energy, just compression.
Okay.
Like a diesel car.
Good. So it's quite simple.
You need also sometimes to put the oil to the engine. So we have here the lube oil pump, and basically engineer is checking the level. Our engine is consuming, for example, 5-10 liters per week with the small load. You have it in the book, or you are just looking to the...
Start from beginning. This lube oil pump, why do you need it?
You take the lube oil from the storage tank
to the engine, to lubricate the engine.
Yes. And you have here the hose, and you're just putting the hose to the sum of the engine and the top of the element. Exactly same like you're doing with the car.
From the lube oil tank, it's going through these lube oil pumps.
Yes, lube oil lines here.
Through this hose.
Yes.
And then you connect it to the engine, and you top up the level in the sump.
Exactly.
Okay, good. So, now let's switch to another subject. Which one you want?
Cooling system, for example.
Cooling system, so cooling this engine. Okay, let's go to that.
And the thing is that this engine doesn't need any external pump, electric. It has the pumps here. And this pump is cooling you all the body of the engine. And this water, what we mentioned before, is going to the deck, where are the battery of the radiator. So
this water is coming from our cooling system on the deck.
Yes.
There is no storage tank or something like that?
No, there is like an expansion tank.
Okay, but anyway it's a closed system, same like in the car.
And if you have the leak, you need to go open the valve.
Okay, if this was conventional engine, where would this water be coming from?
We get this water from the seawater.
So you would get water from the sea chest, then the filters, and then it would be going through the engine.
Not now, because the new engines, they have fresh water in the system. So first you're taking the water.
Okay, then you have heat exchangers.
You have heat exchanger, and the seawater is exchanging the heat between the fresh water.
Okay, this is another way of doing it. So one way of doing is conventional, where the seawater is going through the engine.
To the engine, but it's finished now.
And it's cooling. Then a bit more advanced system is when you have seawater going through the heat exchanger, cooling down the fresh water, which is going to the engine. And you have specialized systems for vessels like this, where you have a closed system which is circulating water.
You might have also the radiator here, so you don't need any lines.
Yeah.
It's just
same like we have on emergency generator.
Yes.
All right. What's this thing here?
This is the control cabinet with the alarm system. If you will have the failure of the cabinet in the control room, you can do all the operations and check all the alarms here. So it's like a backup of the screen
Okay.
We have in the control.
Okay, so it's a local system.
Yeah, additionally, Caterpillar is so good, they feeding the engine with the original panel also. So we have like a 3 redundancy, we can say.
Okay.
This panel is doing the job, then this panel, and we have the panel in there.
Okay, so if those two fail, you can still run it from there.
Yeah, from the local panel, you know. You can normally start it, stop it, and do everything.
Okay, good, good. So, who does the maintenance of this? If you are engine cadet, you came on board, what would you have to know about these little things?
I think they should start from the beginning, so the construction of the engine, whatever, what the engine needs to run. Okay. And then I think the guy who never been on board should be learn these basics, you know. So you checking the lube oil, here is the stick. You should have certain amount of the oil. It's written on the also stick.
Okay.
Yeah. Like a Caterpillar has like this.
Okay, different engines can have different ways of checking that. That's
then
alright.
You should know about the cabinet, how to check the parameters.
How to check what the alarm means and all that.
You can control everything and you should write the logbook, you know. The important thing is also that we need the fuel, of course. So you should know where the fuel filters are, how to react when the filter is blocked. You can always close one filter, change it on running engine, it's no problem, you know. Another thing is that for this one you need to know where is the fuel located. So we have the tank there. And basically on every rig or ship it's done like this, that you have the storage tanks that you're keeping the fuel spare when you get it from the ship or on the hose or whatever. And then you have this one, it's a purifier of the fuel.
Okay.
And you dirty fuel, it's not maybe dirty, but you don't know the condition. It's purified to the day tank or service tank. And then from service tank it's going to the engine.
So, from storage tank, it's going to the purifier.
Yes.
Over there, all the is cleaned.
Yes. And then it's going to the service tank.
Then it's going to the service tank. From there, it's going to the engine.
Yes. And these boxes here, you can show, these are the transformers. So it's quite big boxes and it's very hot there.
Welcome to Transformers. Tell me more about this one. If I was engine cadet, what do I need to know about this?
It's a centrifugal heater, we can say. It's driven by the shaft, an electric motor.
So electric motor runs the shaft?
Yes. Run the bowl, and the bowl is closing and opening, and the centrifugal force is removing the deposits from the fuel. Particles, deposits,
yes, okay.
Then every hour or whatever we need, it's closing, opening by the water and air, and the and then clean fuel is going to the...
And where all the going?
It's going to the sludge line, sludge tank.
Sludge line, yeah. Okay. So and then to the sludge tank,
yes, yeah? Under the purifier or in engine room there is a tank for the dirty oil or dirty sludge.
Okay, good.
What else?
These are the controls, right?
Yeah, this is the control from the program. So you see how does it work. I can even stop the program, you will see. So I push the button, the light is off, so I know which valve is working, not working. And then purifier is doing everything automatically. And there is my power panel.
Okay. All right.
Yeah, now you need to wait because I will come back here. I will push the button. And in every engine room, you have the also distribution board. It's the 480 equipment. So for example, we have the power here for the fans, we have the power for the purifier, for the compressor. If you're doing any maintenance, you should shut off the power, then you're putting the padlock. Here is the place for the padlock, you're making isolation.
So over here you can turn off all the machinery.
Yeah.
So what do you have here?
We have, for example, the supply and exhaust fans.
These are fans.
Yeah.
What else?
Fuel oil transfer pump, you can transfer between engine rooms. We have the lube oil pump for the engine, this fuel purifier, fresh water pump for the people living there, the radiators for the engines, and you know, some small machinery also.
Okay, good. So now we learn about the engine. Okay, turn it off. Ryan! Znači, ovaj taj generator, alternator, ovo gorivo kao on sad gori, znači separator ga pročišćava i tako dolazi do generatora. Sam je timonjer tu nešto upao. Okay, so from the engines I think we can go to the thruster room so you can show them how the thrusters are running. Idemo vidjeti thruster. All right. Vrata se trebaju zatvarati, inače svira alarm.
Hrvatska.
Ah, it's nice and quiet here.
Yeah.
So, what is this? Where are we?
We are in the azimuth thruster room.
Thruster room, yeah. Okay.
So it's the one of the 4 our thruster rooms that it's moving the propellers and converting this power. What we
okay,
talk.
so this is azimuth thruster,
yeah,
which we can move 360 degrees around.
Yes.
What's the big blue thing?
The big blue thing is the motor.
So this is electromotor, yeah?
Yes, and you can show these cables. These are the 690 cables. They're so big.
690?
Like my hand.
Okay. Big cable.
Big black thing.
Yeah, big black thing, okay. Huge cables.
Yeah.
Good.
And here we have also conversion of the power.
Was this painted last time we were here?
Yes.
You sure?
Yes.
Okay.
We have here conversion of the power back to the mechanical force, you know, and there is a coupling.
So this is where it happens. Electric motor, this electric motor.
You can mention also that it's a 90-degree thruster. So basically, here is the actual shaft.
Wait. So, electric motor is here. All that power from the generator coming to this motor. Then it's running.
Yes.
This is the shaft.
Shaft is turning.
There
is a 90-degree gear.
So.
And the shaft is going to the sea.
And shaft is going down to the thruster to the sea, yeah.
Yeah, and it's moving our propellers and you know.
Okay, so this is how we spin the propellers, and
here is the steering pumps.
These are steering, yeah. 2 of them.
So basically, thruster is rotating like this, and then, for example, we want to move the ship.
If you want to turn the thruster,
and it's turning opposite way. If you want to turn more. And
okay.
These 2 pumps moving this.
And these 2 pumps, they are moving it around, right?
Yes.
Okay, let me I need to find a better angle. Okay, yeah. That one and this one. So those 2 pumps are turning the thruster 360 degrees.
Dobre.
Nije dobro. Alright, so this is the thruster, this is where the conversion of energy happens.
You can also add that this ship must be in the water to drive it. So where we are in the water, we're using cooling line to cool the engine and the motor and the...
It's alright, I don't need to say that. Ships are usually in the water.
Yeah.
They're not gonna be probably working on a ship like this, so they don't give a...
Yeah, but then normally there is always cooling system like we have. Pump, valves, and the water is going to the motor and...
Good. Ooh. What's this?
What? This box?
No, these little thingies down there.
This little thing is the thermometer.
Thermometer. Okay, so you know how cool is your water, right?
Yeah.
Good. Everything. That's all?
You can also show them maybe the steel.
What steel?
This panel.
No need to go in that much details.
Okay.
This is steering panel and controls for the thruster.
This box here, it's a local AC unit. So when we're running the thruster, you want to cool down everything, you're starting up this box and it's air conditioned.
You know, on my previous ship, that pipe over there, the white one, bursted when we went to shipyard. Someone replaced it. They put plastic one. Filled up the thruster room. $20 million of damage.
Yeah. Another thing is this unit looks too small a little bit, and plastic pipes are permissible, but it must be well
no, the insurance did not cover it because it was plastic.
If it's cooling line, I don't think so. Yeah. If it's drained, maybe yes. Yeah.
Insurance did not pay for that.
So somebody needed to pay this 20 million.
Yeah. A lot of money. Actually, 2 thruster rooms. We had 6 thrusters over there, and 2 thruster rooms were connected. They forgot to close the door.
Maybe that's why you're working there. You needed to find a new job.
This is why you have these thingies. These doors needs to be closed.
It's a watertight door.
Exactly, but there is a sensor up there, and this is why they need to be closed.
This is according to the rules that if we will flood the room, we have the redundancy, we will not flood.
Exactly, it will not flood the rest. When this is open, there is alarm on the bridge.
Yes.
Which is stupid, by the way.
No, we have actually first alarm in the engine. What's stupid, by the way? Because we need to accept.
Stupid is because I need to get up from my chair to turn it off.
Yeah.
Should be Wi-Fi controlled or something. So, wait, what else?
We go to the another engine if you want. But there is same equipment.
It's the same.
Yeah.
Show me some pumps, some other devices.
Okay.
So,
we have a lot of nice personnel there. Representative from the Louisiana state. Confederate.
Yeah, Southern.
You can show these big boxes.
What are the big boxes?
It's a sewage treatment plant.
Sewage treatment, so it's where are all the goes, right?
And the water from the showers and the toilets.
Okay, so how does it work?
The most important part is these holes. So everything is going to these holes, and it has 3 chambers. The first chamber is collecting. The other one is aerated by these compressors, and the bacteria are growing. And in the last one, we're doing the chemical treatment. So you're using the hypochlorite, and hypochlorite is injected to the mixture, and then we can legally, proper way, discharge into the sea. Before we discharge into the sea, we're using the dechlorination. Yeah.
So, all the comes from that pipe over there, right? 3
pipes.
Black water.
Yes. Because require
sanitary, black water, okay.
No, it's a vent line, by the way. But yeah. Basically everything is going there.
Okay, so it's coming through that pipes in the first chamber. What happens in the first chamber?
Just collection is.
So collection is in the first chamber.
Yes.
Okay.
Then you have this hose is going there. From the second chamber to the third chamber.
No, wait. What happens in the second one?
Overflow from number 1 is going to second, and in the second...
So the hard stuff is left in the first one, right?
Yes, but it's waiting to be more soft.
Yeah, okay.
And then...
So when it goes to second one, it's already a bit cleaner, right?
Yes.
Where do you have bacteria?
In the second chamber.
In the second chamber you got bacteria which is eating all shit basically, right?
Yeah.
Okay.
You need the air to give energy to the bacteria.
And you are giving air to bacteria so it can live. Okay.
And the third one is a chemical treatment.
And in the third one you put chemicals inside.
Yeah.
Like that.
And it's dosed by the pump.
This is dosing pump or something?
Yes.
And so okay. So you have 2 of these plants, right?
Yeah, because if one is broken, you have to accumulate it somewhere.
Yeah.
But there is always emergency option. You can use the overboard line. But according to the rules, we should have the padlock and it shouldn't be idiots.
Okay.
You can get the maybe not 20 million, but
So this is a sewage treatment plant. This is another sewage treatment plant, right?
Yes.
Good.
Well, we're just making a movie to the academy.
So how many people can in this chamber?
Oh, I have no idea.
Oh.
No, 100 will be over.
Where do you see the capacity? Model size.
Yeah, but you don't know how much people are sitting.
Anyway, this ship has capacity of 150 people. It's a lot of
You have also here like a hydraulic, I mean, flow. Yeah, it's 11 cubic meters, it's a lot.
11 cubic meters per day, yeah. It's a lot. 11 tons, yeah. You can't really fill that.
Yeah. And here you have the discharge pump. They call it macerator pump. It's a impeller. It's anything what will stay solid.
Okay.
If we don't want it, it will be additionally, you know, damage and
Okay.
discharge.
Good.
We have also 2 units, redundancy, 2 blowers, 2 discharge pumps.
Okay, so there's a lot of redundancy on this ship.
So what, you want to visit another engine room?
Any other devices you got here? Any special pumps, fire pump, ballast pump?
In this room, no.
You must have some.
No, there is a fire pump in the here in the corner.
All right.
Yeah. This is like a general service pump.
General service pump. What does that mean?
It means that we can use it for the bilge system, and also we can use it for the ballast system, and we can also use it for the fire system. So you need to
bilge, ballast, and fire system. So we can use it for anything we want.
Yeah, and we think we need. But important thing.
So it is connected to all the pipes.
Yeah. There is a filter.
Bilge, ballast, fire pump number 2, which means we have number 1 also. So over here it looks like it's connected to ballast system, right?
Yes.
And this is how you operate the ballast system, manually.
Yeah, you have the manual valves opening and you see the position of the valve.
Okay.
Yeah. This is in open position.
Okay.
This is closed. And this type of the valve is called butterfly.
Butterfly valve.
Yes. Flat one.
Good. These valves, usually on ships, depending on the type of the ship, they can be remotely controlled.
We have one.
Yeah. Then you have what you call solenoid, right?
Actually, it's not a battery. No, it's butterfly. And there is an actuator. So if you are in the control room, you have the switch. There is show position. It's enclosed now. You have the cables, so you have the indication, the power, you push the button, open close.
So you have remote control on these kind of valves. So let's go back to ballast.
Maybe we show the batteries also. Why the batteries we have.
Let's talk more about ballast system.
No, because it's not my system, it's your system.
That's why. So, you charge ballast and you discharge ballast with this pump, right?
You can. Maybe I will start questioning about it. Which
Shut the
primary for balance control?
Yeah.
No, but of course not this pump, because we have the designated ballast pump for it.
That's what I'm saying.
Yeah. So this is like a general service pump, like a spare one, you know.
Yeah, I know.
Yeah.
So, but with that one, you can load and discharge all the ballast depending on how you open these valves.
Yeah, configuration of the valve, yeah.
Okay, so you just need to follow the line and open the valves which you want to open.
And you need to know what you're doing.
You need to know, yeah, that's what I was going to.
Capsize the ship.
Yeah, that was what I was trying to say. So you need to understand how system is working.
You have to know the structure of the ship, that we can say it's a big bowl with the chambers, you know.
Yeah.
You can't do like this, that you put all the ballast one side, because it will be...
So a good idea would be to take a drawing and see what you're doing.
That's why you've been studying so long in the ship, and it's cool.
Usually deck officers do that, and sometimes they do that.
They need to do something, you know.
Yeah.
Yeah. Let's go to batteries. Sean.
Okay, let's see the batteries.
You can mention maybe about the beach system, that all the compartments on the ship, like rooms, whatever, that they have contact with the water through the bulkhead, might be leaking.
Okay.
There are old ships, 30, 40, 50 years old, that can be cracked or whatever, then you're getting the water inside. Or we can have the internal leak on the pipework or the valve.
Okay.
Then you need to use each pump. We can always use this pump also. You're opening the valve. No, I can't open this again. You're opening the valve, you're starting up the pump, and this water is going to the beach tank.
Okay.
We have the regulation now that no any water from the ship should go out directly. Even not the ballast water, because it's going to the treatment ballast system. But this water is, you have black valve and you have black stripe here. It means it can be contaminated with something. So
okay.
Basically we are pumping this water to the beach tank, and then we can discharge legal way with the oily water separator.
Okay.
And this is globe valve.
What kind of valve?
Globe valve, it means it has body inside and...
Okay.
Yeah.
Good.
On every ship we have the batteries, and what the batteries does, it can be in the worst case scenario that we don't have any power here. So
okay.
Something happened to the generator, somebody was drinking, somebody was not there, and something happened. And there it's a blackout. We call it like a blackout.
Blackout, okay.
Yes. And the thing is, you need the batteries to keep the emergency lights, for example. You need the batteries to keep the emergency control. If you want to start up everything from the beginning, you can do it with the air and the fuel what we have all the time. But the problem is, all the breakers now, so these cubicles, what we show on the bus bar, to
okay.
connect the generator with the bus bar and the outputs, they need control power, and the control power is also going from these ones. It's like a 24 volt now. And all these batteries, it might be 12, depends on the construction of the ship, but all these batteries should be checked, and we have the chargers there. So, like maybe I show how the batteries look. It's like a truck batteries. You have the cables plus minus, and you have like a you know, redundancy also there. And here is the charger. What's the charger doing? I would say it's preparing ourselves for the okay. So if something happened to the ship, the charger is all the time charging the batteries. We have the alarms also there, whatever, and they always ready and charged. We don't want situation like with your car. You're going to your car and then...
Okay, no. So in case of blackout, this battery will do what?
They will give us the control voltage to the
control voltage to the bus bar.
Yes.
Where all the breakers are, which we showed in the beginning.
That the batteries can supply some of the lighting. It's possible also. But we
okay, they can't, doesn't matter. But the primary purpose is to supply power to the bus bar.
Yes.
All right.
Control power, it's not the main power.
Control power, good. So what else you got here?
We have the oily water separator also, what they should know.
Oily water separator.
We can go there, but there is noisy.
Okay, what does oil water separator does?
Maybe you show it.
Okay.
Yeah, and then we will tell.
All right.
Air protection should.
So we just seen
this green box or green unit. It's oily water separator.
Oily water separator. What does it do?
And all the residues of the oily water or beach water are going to the tank, and then the guy is coming here, starting up this oily water separator, and you're using the air, mixture of air, water, and there is a filtration system to discharge with the proper limit. There is 5 ppm or 50 ppm, depends on the zones.
Oh, okay, wait. From where is it coming, oily water?
From the oily water tank.
Oily water tank. It goes to that oily water separator.
Yes.
That separator separates
separating you the residues against the water.
And you are left with almost clean water, right?
Yes.
Which you can discharge overboard.
Yes.
And
residues are going to sludge tank.
To sludge tank.
Yeah, and the sludge tank is the
so that enables you to get rid of the water, which is not so bad, and the bad stuff stays on board.
You need to send it to the ship or to the shore site or whatever.
Okay.
Yeah.
So
it works like this.
Good. So oily shit stays on board, water goes out.
Yes.
Good. What else we have?
We have, for example, the hydrophore tanks with the pumps. This is the blue stuff. What's giving you the water for the washing machines, for the washing, for the showers, all the stuff like this, accommodation.
Hydrophore is just a hydrophore pump.
Yeah, it's normal, big tank, you have the air pressure.
It's not a rocket science, you got it back home now.
You have the reverse osmosis to make a water also.
Yeah. Ah, this is interesting. It's in this one?
Yeah.
But
you can show it.
Can you switch the engine so we can...
Yeah, of course.
Okay.
We can show how to do that.
Okay, now we will switch from one engine to another.
Yeah.
So
basically, I should go to the engine room and check the oil level and everything. We check it already on the engine number 3.
So first you check engine number 3. That's all
conditions
good.
And all the stuff like this, and you know.
Okay.
And then you have the engine in the auto mode because it's a full automatic system. So we're keeping the engine all the time automatic. But if I want to start it, I prefer to heat up the engine a little bit, you know. Okay. Then I'm changing to the manual mode.
So you're changing to the manual.
Yeah. It's in the manual, you have the icon of the hand there.
Okay.
And you can start the engine.
So you just started number 3, right?
Yeah.
Yeah, I can hear it running.
Yes, the air is used.
Oh yeah, I can hear it.
Yeah. And now you can see the engine is running and also it's moving the alternator. That's why you have the indication.
Yeah. Now we have voltage, yeah?
No, we don't have voltage. You have the initiation of the voltage on the alternator, but you don't have voltage between the engine and the busbar.
Okay.
It's the indication, let's say, that the engine has proper revs.
Okay.
The revolutions, the speed. And here, 60 Hertz, it's showing you also that the alternator is healthy. Everything is okay. So basically it's like this, that to get the power, you need to excite the unit, what we'll be doing, and then you're giving the power to the diodes and everything, and it's giving you the power. So let's say it's 10 minutes, whatever, to heat up.
Okay.
It's already heat up because you have 50 degrees or 60 in engine room. But it's also about the cylinders and the, you know, the injection system. And let's say that it's okay. We have very low load, so we can just do it for the show. And basically, what I'm always telling the people, here is the main breaker for the generator. So this tube connecting us to the bus bar. And it's the most critical part now. Engine is running, and I need to connect the power from the engine to the ship's power.
Okay, so now you need to connect from the engine to the ship.
And how does it look inside?
It goes through this thing.
Yeah, you have 3 pins, big pins. These are the fuses with the tulipan connections, they call it. And they entering the, there is a chassis inside, it's moving, and they entering the sockets and connecting the bus bar. And basically now I can always do it manually also. You have the lever here. So if there will be any problem with the breaker, whatever, mechanical, we have always electrical. We have always possibility to, like we call it, pump it mechanically. You know?
Okay.
And then we pushing the button.
And now it's connected.
Clutch icon, yeah. And this is synchronization. 5 to 12 here. The system will know that the engine is in same factor as the other one, and it will load up the engine.
Ah, it will.
Yes. Yes. And it's a big power here, and I'm telling everybody, never stand in the way of the breaker, because if you have the explosion of the breaker, I was on the training, the power is so big that this cube will fly. And also you get the flames up, and you can also show it. Here you have the vents. Yes, here you have the vents. So if there will be explosion, the flames and the smoke and the energy is going over there. And also that's why you have space here. The bus bars never are built to the top, you know, because it will be, you know, melting. Okay. That's why if you pushing the button, always stay like this, you know, in the angle, and nothing will happen to your balls, you know.
Yeah.
Because I want to go, I want to go to Rovini, you know. Yeah. And basically, you can see now that we have the all the parameters proper. The difference is we've got the current.
Okay.
So it means we are connected to the bus bar, and here you can see the power. It's a 0.18 megawatt consumption.
Okay.
Yeah. And if everything is okay and we're happy about it, you know, you can go to the another engine. Maybe we will make a blackout, you know. And now we need to stop this engine. So basically, when it's running on board with the other one, you don't need to desynchronize it, because it's like this, that I will just cut the power off, and the other engine in the proper factor will take over everything, hopefully. Yeah. So the breaker is off.
Breaker is off.
Yes. And we are on the another engine on the power. And you see the current is off.
Okay.
Still is the volts and the hertz, because it's showing, like I say, the healthy alternator. And now you're pushing the stop button. You can do it straight, because this system is so smart. It will not allow you to stop the engine straight. Okay. So slowly it's going to the cool down sequence. And
so it's gonna turn off automatically?
Yes, but in the cool down sequence that we will not break anything, you know, like a thermal stress and you know. Yeah.
Smart engine.
Very smart.
So you see here. So
it's another 5 years study for you. Yeah, but now I will maybe push the button. No. No, it will.
You can see the arrow falling down.
It will override. If you need to stop it, nothing will happen. Because we want quiet.
Nice.
Yeah, slowly you see, slowly the voltage is going down. It's not like this, that you don't have voltage. Look here. Engine was stopped maybe 30 seconds ago, and still voltage going down. That's why you must be careful if you're working on the alternator. It should be stopped, but also should be earth. You know.
Okay.
Yeah, we are okay, so we can go to another engine room.
So now we switch the engine, and port side engine room is quiet. It's not so quiet. Sve ventilatori se lipaju red.
So it wasn't dangerous.
So
you got your blowers like you need on that side since you got an engine on it?
Yeah, but they started the fence. Yeah, they started. That's why I was possible.
oily water separator,
Yeah.
we mentioned that.
Yeah.
It's separating
You have
oil
pumps,
from the water.
Yeah, pumping, and it's like the important thing is this cell that it's giving you the alarm if you're passing if the water is dirty, it's redirecting you back to the oily water tank. If it's okay with the limit, we can discharge.
Okay. What's this? These pumps.
These are the freshwater pumps for the hydrophone.
Okay, so these are supplying what? Water to the accommodation?
Yes, water everywhere. The fresh water, the drinking water.
Fresh water, drinking water, yeah. What's that big blue tank over there?
This is the hydrophone.
Hydrophone,
So
okay.
like at home. You have the air level there, the air pressure. You're building the required pressure. Whatever.
So it's building pressure inside.
Chuck's baby, he wants more pressure. Yeah.
So wait, it's building pressure inside. How is it building pressure
You
inside?
have the air from the top.
Okay.
And you have the water from the bottom. And
Okay.
it's balancing you the level. And then water is sent to the accommodation with the pressure of the
Water is sent how? By air pressure?
Yes, by air pressure.
Okay, where is the air coming from?
From the line, from the bottle.
From that bottom.
Yes, but you have to remember that for the starting the engines you have 30 bar air. For these purposes you have 6 bar.
But it's coming from the same one?
Yes, but you have the reducer for regular.
Okay.
Here is the reducer. You can show. Yeah. On the top there is a regulation bolt, and you can adjust the pressure
okay.
what we need.
So the same air receiver which you use for starting the engine, you are using it to give pressure to hydrophone.
Or also to the general purpose
Yeah,
connection.
okay. So then you got water and air inside,
Yes.
and this pressurized air is pushing the water.
Pushing the water through the filtration system and the UV sterilizer.
Filtration system and
it's for the
UV.
particles, and this is for the bacteria.
UV sterilizer to kill the bacteria.
Like a sunbed.
Okay. Ooh, it's green.
There's no bladder, it's just straight air pressure.
Yeah, yeah.
On a smaller system, they got those bladder tanks.
Bladder. Yeah.
Okay, what are the pumps for then?
They topping these tanks with the water. So they keeping always the water in the middle, and then we have the consumption.
Okay.
Spare water and
UV sterilizers.
yeah, it's the
These
power
are-
of the lamps.
Okay.
And
Yes.
here,
So this is how we get water to your cabin, to your toilet, to the galley.
this is how we make a water.
This is water maker, right?
Yes. We can call it water maker or reverse osmosis.
Reverse osmosis.
Yes.
Reverse osmosis water maker. Okay.
So how does it work? We want to.
How does it work? Yes, that's what we would
It's
like
simple.
to know.
It's really simple.
It cannot be simple. Look at all this
It is
shit.
simple. What
Wait,
we have
I need
here,
a better angle. Yeah.
yeah, maybe from that side.
Yeah,
You
I
have
think
everything.
from. Yeah. Okay.
Here, show here.
Okay.
We need the seawater to make a fresh water.
Okay.
And the thing is, for these units, I need to start the seawater pump,
Okay.
get the seawater to the unit.
Okay. So you supply seawater by the pump. Okay.
Then what will happen with the water? To make a fresh water with the reverse osmosis,
So the process is called reverse
Yeah.
osmosis.
Yeah, yeah.
Okay.
And basically you need to compress the seawater, the salty water, to the certain pressure, go through the membranes. Membranes, it's like a core material inside. I would say it's some kind of the filter or material that it's separating you the salt and the minerals from the water.
So what you're doing, you're pressurizing that water
60 bar,
60
yes.
bar
Pushing
and
through this unit.
pushing through that,
Yes.
what is it called?
Membrane.
Membrane.
Yeah.
Okay, and then salt is left inside and water
Salt
goes
and
out.
the dirt are left inside, and you have two outlets here. And you're making a fresh water, and you're making a brine. Like brine, it's like a, you know, residues and
Yeah.
you know. And for this purpose, you have the special high pressure pump here. We call it cat pump.
Okay.
It's 3-piston pump, very strong, and she's making 60 bar.
Okay, so very strong pump for this
Electric
purpose.
motor for it, yes.
So yeah, it's quite simple.
It's really simple. Additionally, when you're making this water, you have the scent filter. Scent filter is like a first stage of the cleaning.
Okay.
So basically, in this filter, you have like a, it can be scent even, but you have some special kind of the material, like how do you call it? Yeah, like yeah, I've seen also something like this that they had balls, different
Okay.
kind of the balls, and then water is passing through, and the sediments and the residues stay.
So it's like mechanical filtration.
yeah, yeah. No, it's not mechanical. It's like a sedimentation filter before the
Sedimentation
membranes.
filter. Okay.
Yeah.
So this is a first stage, and then the membranes are second stage. Yeah. Okay.
No, it's opposite. First it's going to membranes, and then it's going to them. Yeah.
Oh,
it's
for
the
fuck's
first one.
sake.
Yeah.
Just a filter media.
Yeah.
Yeah. Okay. So first it goes there, and then goes there, and then goes out.
Also, you have these small hoses using the chemicals like hypochlorite, or you know that the water is you know, good for the drinking.
Dosing
drinking
pumps
purposes.
and chemicals which you put in the water, kill bacteria and stuff.
Yeah.
Chlorine and stuff like that.
Yeah.
Okay.
And you can make, I think, here 6,000 liters. 60,000 liters per day.
That's 60 tons, yeah? It's a lot.
What we are using a lot also. So.
And we got two of
units.
those.
Yes.
We got 2 units. So 120 tons we can load of water.
Yeah.
And you can run both together, correct?
No, why? Yeah. You can. Yeah. We can maybe show also the heaters there with the water. That you need sometimes hot water because you're not taking shower with the cold.
Shower water, yeah, that's the most important stuff on board. So these are the heaters.
Americans call it calorifier. In UK they call it heat.
We just call it a hot
Heat.
water tank, you know.
or the British call it hot pots or something like this, like a pot, you know. And basically here it's really simple. This water, what we are pushing to the accommodation, is going there, and in these tanks you have the heating coils, the electrical ones.
Okay,
They're heating you
electrical
up the water, and then you have the circulation pump, and it's separated. So cold water is going to the shower with the directly to the blue tanks, and from the green tanks, hot water is going other way.
Okay, so we can heat a lot of water. What's
Yeah.
this, thermostat?
Yes, this is the thermostat. You are setting up the
Okay. All right.
That's
I
about
think
it.
We've been through all the systems.
Yes.
Can we now?
Emergency generator.
Oh, shit! They'll find that. Firefighting system. What kind of firefighting do you have in engine room?
Oh, of course we have conventional water.
High fog, water, mist, fire protection. High fog suppresses fire by discharging a fine water mist at high velocity. High fog fights fire 3 ways: by cooling the space, by blocking radiant heat, and reducing the oxygen that reaches the seat of the fire. High fog has used 90% less water than a traditional sprinkler with equal fire protection performance. The damage is limited to this room. Business continues in the rest of the building without interruption. High fog, protecting people, property, and business continuity.
No, okay.
Safe for us.
Yeah, so it will not then, like you said, it will not damage the generator, it will not...
It's safe for the people.
It's safe for the people, yeah.
Right.
So,
Like a CO2.
this is water mist nozzle, and it will extinguish the generator in case it's required. Yeah, there's one more there.
CO2 system.
So, this one and this one you can start from where? I can start it from bridge, right?
I can start it from the control
You
room.
can start it from control room and
every
locally.
room you have, yes.
In every room there is manual release. Main genset 1, fire extinguishing system, blah blah. Fuel oil purifier. So these are locations where they are.
Yeah. What's covering the machinery? We have 3 things secured by that. And you have the CO2 system.
CO2 system. That's what we use when we want to get rid of engineers.
Yes.
Okay.
Small Auschwitz.
Yeah, small Auschwitz.
Yeah. The thing is about that.
You are Polish.
Yeah.
That's why it's funny.
Any juice?
Okay.
Any juice in the class?
Yeah. And it's no, you know why is it funny? Because we got CO2 system here. We got our Polish engineer and captain is German.
So he can launch it against me.
Yeah.
There you go.
So
The thing is about the CO2 that it will cover all area and it's dangerous for the people because it's taking you out the oxygen.
yeah.
And why we taking out oxygen? Because we want to extinguish the fire.
So this one is harmless for people. This one, water mist, you can activate anytime you want, right?
Even now, I will make you wet.
No
Also,
need.
You wouldn't need containment with CO2. You're going to have containment to be effective. Otherwise, your CO2
Exactly.
will go out as fast as
This
you
one you can activate, it will extinguish fire, but CO2, if you don't seal off everything, if you don't
You're
close
losing
it,
the efficiency.
yeah, it will not be so efficient because you need to get rid of air and pump in CO2.
But another thing is that the regulation is also that you must have a lot of cylinders. That, for example, we have the room with the big bottles.
Yeah.
It looks like a welding gas bottle or whatever. And for this room, you don't need to launch everything. I think like 4 or 6 bottles can be enough. You have spare ones, so it will be pumping.
Okay, so to release CO2, you need to be sure it's all closed. You need to be sure there's no one in the room.
And this is your responsibility. That's why you have the station on the beach.
So that is why it's better to use these ones, water mist, because CO2 should be last resort, right? Okay.
But we need to hire a few Croatian engineers. Then I will be sitting on the beach.
Yeah, no. I feel happy on the bridge with my German captain and Polish engineer and gas.
Yeah, that's about it.
And that's about it. It's not a rocket science.
Yeah, you have all kind of the buzzers and the beacons. Every color of the buzzer means different alarm. You might have the CO2 alarm, so before or if somebody will launch it, you are informed about it, so you have still time to escape. We have also the camera system in all the ship.
No, it's not important. Camera, it's not important. So, Chief, thank you for this nice video. It looks like it's been an hour. It's a real documentary.
We will see each other in Rome.
Yeah.
They knew this beach.
This was our Polish engineer. What's your name?
Wojtek.
Last name?
Itka Wojciech.
Okay, so
Facebook Wojciech Dyniak. Any nice girls.
So when you see him on board, you know to run away. Bill.
This is our advisor, Louisiana Bill.
This is Louisiana Bill, Wild Bill. All right.
Now you turn camera to your face.
Ah, yeah. That's me.
nickname Juan.
Thank you guys.
Thank you.